For decades, astronomers believed they understood the basic role of black holes. These mysterious objects were known as cosmic engines of destruction, pulling in nearby gas, dust, and even light with gravity so intense that nothing could escape once it crossed the event horizon. But the universe has once again revealed that it is far more surprising than anyone imagined. Using the remarkable capabilities of the James Webb Space Telescope, researchers have identified one of the strangest cosmic events ever observed. Instead of remaining anchored at the center of its galaxy, an enormous supermassive black hole appears to be racing through space at extraordinary speed, traveling millions of miles every hour. The discovery has captured the attention of astronomers across the world because it challenges long-standing theories about how black holes behave and how galaxies evolve. The James Webb Space Telescope was originally designed to investigate the earliest stages of cosmic history. By detecting infrared light that has traveled for billions of years, Webb allows scientists to study objects that formed shortly after the birth of the universe. Since beginning operations, the observatory has revealed ancient galaxies, dying stars, and enormous clouds where new stars are born. Now it has uncovered something unlike anything previously documented. Rather than acting only as a destructive force, this runaway black hole appears to be triggering the birth of new stars as it moves across intergalactic space. As the black hole plows through massive clouds of gas, its tremendous motion creates powerful shock waves. These shocks squeeze the surrounding material together, increasing its density until gravity takes over. Once the gas becomes dense enough, new stars begin to form. Instead of leaving behind darkness, the black hole creates a brilliant trail of young stars stretching across an astonishing distance. Scientists estimate that this glowing pathway extends for roughly 200,000 light-years, making it even longer than the diameter of our own Milky Way galaxy. The idea seems almost impossible. How could one of the universe's most destructive objects become part of the process that creates stars? Researchers believe the answer may lie in the violent history of galaxies themselves. When galaxies collide, their central supermassive black holes can interact in dramatic ways. If another massive black hole enters the system, an intense gravitational encounter may launch one of them away from the galactic center like a stone fired from a slingshot. Such an event would send the black hole speeding through surrounding gas at incredible velocity. The observations collected by Webb strongly support this possibility. Additional evidence gathered by the Hubble Space Telescope has helped strengthen the interpretation, allowing scientists to compare visible and infrared observations of the same remarkable object. Together, these observations paint the picture of a black hole that is not simply wandering through empty space, but actively reshaping its environment. This finding forces astronomers to rethink the relationship between black holes and star formation. For generations, black holes have been viewed almost entirely as cosmic consumers. Yet this discovery suggests that under the right conditions, they may also help create the very stars that illuminate the universe. If confirmed by future observations, this could represent an entirely new chapter in our understanding of galaxy evolution. But Webb's remarkable discoveries did not end there. While researchers continued studying this extraordinary runaway black hole, another spectacular target revealed itself through Webb's powerful infrared vision. Far beyond our own galaxy, two enormous spiral galaxies are locked together in one of the most energetic collisions ever observed. The result is a breathtaking object known as ARP 220. Located hundreds of millions of light-years from Earth, this galactic merger shines with incredible intensity, producing vastly more energy than the Milky Way. For hundreds of millions of years, gravity has slowly pulled these two galaxies together. As they collided, gigantic clouds of gas were compressed, igniting an explosion of star formation unlike almost anything seen nearby in the universe. What Webb observed inside this chaotic system would give astronomers one of the clearest views ever obtained of a galactic collision in progress. That remarkable story begins next. As the James Webb Space Telescope continued examining the spectacular collision known as ARP 220, astronomers found themselves looking into one of the most extreme environments ever observed in the nearby universe. This is not an ordinary galaxy. ARP 220 is the result of two massive spiral galaxies that began merging hundreds of millions of years ago. Over countless generations, gravity pulled them closer together until their stars, gas, and dust became intertwined in an immense cosmic collision. Unlike dramatic explosions that happen in moments, galaxy mergers unfold slowly over hundreds of millions of years. Yet the consequences are extraordinary. Enormous clouds of gas have been compressed by powerful gravitational forces, creating ideal conditions for rapid star formation. New stars are appearing at a breathtaking pace, transforming the heart of the merger into an enormous stellar nursery. Webb's infrared instruments allow astronomers to see through thick curtains of dust that hide much of this activity from visible light telescopes. What emerged from these observations was a remarkably detailed picture of chaos and creation existing side by side. Near the center of ARP 220, scientists identified two brilliant galactic nuclei. These glowing cores are the remaining centers of the original galaxies, still orbiting one another as they continue their slow journey toward becoming a single, larger galaxy. Around these central regions, enormous rings of gas and dust continue feeding the birth of new stars. Everywhere Webb looked, signs of intense activity appeared. Long streams of stars and gas stretch far beyond the main body of the galaxy. These tidal structures were pulled outward by the tremendous gravitational forces generated during the merger, serving as lasting evidence of the violent interaction. The telescope also detected intricate networks of glowing dust and complex organic molecules spread throughout the system. Although organic molecules are common throughout the universe, their presence helps researchers understand how the raw ingredients for future planetary systems are distributed during major galactic events. Every new observation helps scientists build a clearer picture of how galaxies grow, evolve, and reshape themselves over billions of years. Yet perhaps the most astonishing surprise was still waiting. As researchers examined some of Webb's deepest observations, they focused on incredibly faint galaxies located near the edge of the observable universe. These tiny points of light represent objects whose light has traveled for more than 13 billion years before finally reaching Earth. Looking at them is like looking back through cosmic history itself. At first, many astronomers questioned what they were seeing. Some of these galaxies appeared far brighter and more developed than theoretical models had predicted for such an early period in the universe. Could these really be among the first generations of galaxies? Or was there another explanation? Scientists carefully analyzed the galaxies using spectroscopy, a technique that separates light into its individual wavelengths. Every chemical element leaves behind a unique signature, allowing astronomers to determine an object's composition, distance, and motion with remarkable precision. The results confirmed that several of these galaxies truly originated during the universe's earliest epochs. Instead of finding only small, slowly growing systems, Webb revealed galaxies that had already accumulated enormous numbers of stars surprisingly soon after the Big Bang. These discoveries are encouraging researchers to revisit long-standing models of galaxy formation. Rather than overturning everything scientists know, the new evidence suggests that the early universe may have evolved faster and more efficiently than previously believed. Powerful bursts of star formation, rapid gas accumulation, and repeated galaxy mergers may have allowed some galaxies to mature much earlier than expected. Each new observation reminds us that the universe still holds countless mysteries waiting to be uncovered. The James Webb Space Telescope was built to answer humanity's oldest questions, but with every discovery it also raises entirely new ones. From a runaway black hole that may ignite star formation, to a spectacular galactic merger overflowing with newborn stars, and finally to unexpectedly mature galaxies from the dawn of cosmic history, Webb continues to reshape our understanding of the universe. Every image it sends back is more than a beautiful photograph. It is another piece of an enormous cosmic puzzle, bringing us one step closer to understanding where galaxies came from, how stars are born, and how the universe became the extraordinary place we observe today. And if Webb's discoveries so far are any indication, the greatest revelations may still lie ahead.